When you gaze up at the night sky, what do you see? Stars, galaxies, planets, perhaps the vast, endless stretch of space. But what if I told you that everything you see, every star, every planet, every nebula, and even you, only makes up a tiny fraction of the universe? For decades, scientists have struggled to answer a baffling question. If gravity holds galaxies together, why aren't they falling apart? The answer led to the discovery of an invisible force called dark matter. And if that wasn't mind-blowing enough, astronomers later found something even more mysterious: an unknown energy pushing the universe apart at an accelerating rate. They called this force dark energy. These two cosmic mysteries, dark matter and dark energy, are completely reshaping our understanding of the universe. Today, we'll break down exactly what they are, why they matter, and how they could change everything we think we know about physics. Get ready to explore the unseen forces that control the cosmos. In the 1930s, Swiss astronomer Fritz Zwicky noticed something strange while studying the Coma galaxy cluster. When he measured how fast the galaxies were moving, he found that they were moving so fast that they should have flown apart, unless there was something invisible providing extra gravity to keep them together. Then, in the 1970s, Vera Rubin made another shocking discovery. She studied the rotation of galaxies and found that the stars on the outer edges were moving just as fast as those near the center. This went completely against what physics predicted. Think about our solar system. The farther a planet is from the sun, the slower it moves because the sun's gravity weakens with distance. But Rubin found that galaxies weren't behaving this way. Their outer stars were moving as if there was some invisible mass pulling them in. The only explanation? There had to be a huge amount of unseen mass inside and around galaxies, something we now call dark matter. How much dark matter is there? Dark matter is everywhere, yet we can't see it. Scientists estimate that ordinary matter, stars, planets, everything we see, 5% dark matter, 27% dark energy, 68%. This means that most of the universe, about 95%, is made of something we can't see or directly detect. What could dark matter be? Scientists have spent decades trying to figure out what dark matter is made of. Here are the leading theories. WIMPs, weakly interacting massive particles. Hypothetical particles that barely interact with normal matter but have mass, meaning they could create gravitational effects. Axions, ultra-light particles that might explain some of dark matter's strange properties. Primordial black holes. Some researchers think dark matter might not be particles at all, but instead be tiny black holes formed in the early universe. To find answers, scientists have built massive underground detectors, such as the Xenon experiment in Italy and the LUX Zeppelin detector in the US, to try and catch dark matter particles interacting with atoms. But so far, dark matter remains completely invisible. Yet, even though we can't see it, we know it's there, because without it, galaxies and even the universe itself wouldn't exist as we know it. For most of history, scientists assumed that gravity would eventually slow down the expansion of the universe. The logic was simple. The Big Bang started the expansion, but gravity should pull everything back together over time. However, in 1998, two teams of astronomers studying distant supernovae discovered something shocking. The universe isn't just expanding, it's expanding at an accelerating rate. This made no sense at first. What was pushing galaxies apart, making the universe expand faster instead of slowing down? The answer? Dark energy. How much of the universe is dark energy? Dark energy is everywhere, and it is by far the dominant force in the universe. Dark energy, 68%. Dark matter, 27%. Ordinary matter, 5%. This means that most of the universe is made of something we don't understand at all. What could dark energy be? There are a few possible explanations for what dark energy might be. The cosmological constant, vacuum energy. The idea that empty space isn't actually empty. It has energy that causes space to expand. Quintessence, a hypothetical energy field that changes over time, which could explain why the universe's expansion is accelerating. Extra dimensions. Some physicists believe dark energy might be a result of interactions with hidden dimensions beyond the ones we experience. Regardless of what it is, dark energy is shaping the future of the universe in dramatic ways. The entire history of the universe can be understood as a battle between dark matter and dark energy. Dark matter pulls everything together through gravity. It keeps galaxies intact and gives structure to the universe. Dark energy pushes everything apart, making the universe expand faster and faster. What happens in the end? There are three possibilities. The Big Crunch. If dark matter is stronger, the expansion will slow down, and the universe will collapse back into a singularity. The Big Freeze. If dark energy keeps expanding the universe, galaxies will drift apart, stars will burn out, and the universe will become a cold, dark void. The Big Rip. If dark energy keeps growing stronger, it could eventually tear apart everything, from galaxies to planets to atoms themselves. Right now, it seems that dark energy is winning, meaning the universe is headed toward an endless expansion. Dark matter and dark energy are two of the biggest mysteries in modern science. We know they exist because we can see their effects, but we don't know what they are. With new experiments, powerful telescopes like the James Webb Space Telescope, and breakthroughs in particle physics, we are getting closer to unlocking the secrets of the dark universe. What do you think? Could there be new physics beyond what we currently understand? Let me know your thoughts in the comments and subscribe for more mind-blowing science videos.